Welcome to this Trimble Business Center video tutorial. In this video, we will look at our relative adjustment result. I called it in the previous video reconstruction, as this is the process that is done during this step. So we finished a relative adjustment for the tutorial data, aerial survey data. You see now there is a button apply adjustment possible to be done. And hitting the button, this will influence the orientation of each single image. So before we do this, let's take a look here before we apply it to our data. And for this, we will need to activate the image frame. So you can go to Home and activate the View Filter Manager and then choose the tab here and hit Image Frame. And then we will open here a 3D view. You can do this also from home. There's here a 3D view button or also this icon here. And when we take now a look at the 3D view, then we see these frames here appearing. When you keep the middle mouse button pressed, you can rotate the whole thing. And now we can see here now these frames. And you see the frames, they are not straight looking down. They are already a little bit rotated. And this comes from the GXL file that we imported at the beginning. You can also see these round circles. So each of these round circles is, in our case here, the position from our camera. And the frame itself represents the rotation of this photo. And therefore, this will now be changed. So when we hit the apply button, these rotations will then change because we were running a reconstruction, so this relative adjustment, and this will then influence this part. A small fun fact, which is nice, when you keep the right mouse button pressed, you can also move it. You can see here our control points, and if you now rotate this part, and we will take, for example, here a look now at the control point 11, and when we now move the center of our photo from this image 11748 on top of 11, so let's here rotate it, and here we go. And we can now see that this is inside this frame. So this is the prediction that this point can be measured in this one. If we take now this other image here, 11730, move it with the right mouse button and with the middle mouse button until we get to it, then we see, no surprise, that now the prediction of this triangle is outside of this frame, and therefore probably we will not be able to measure it. And this is also when you see later on in the control point measurement the predictions, then this is exactly the reason it's not predicted that this can be measured in this frame. So let's move this here again to the side, a little bit like this here, and we will now, I will make here a screenshot. Let's move a little bit sideways so we see more. And then we will apply the adjustment and compare this here with the screenshot. So I will not change the rotation. I go back to process view. I hit the apply adjustment, and then the adjustment is applied. And we can also take the review. I will hit now yes, because we will take a quick look to it. But also what we want is, of course, to now, I will come back to this PDF, but we want now to look in the 3D view. And here we go. Let's make here a quick comparison. So here we go. I overlaid the two results, and well, just as see, I should have used for the other ones blue and for the others orange. But so what is now blue is now here our previous run. So we can see it with these two images to here. And also this one that is straight is now here blue. But that means blue was before, and then we applied the whole thing here. And now we have these orange result. Now we have the blue result. So orange was before, and blue is now, because this is what we get now. And we can see that there's a difference. So that means the orientations of these images has changed, and therefore also the prediction, for example. That means if I would now again rotate and take a look at my projection center here, if this control point can be viewed in this image, and then afterwards I take again the other image from the other side and see if this is now here still inside, then we can here also see now that this can vary, because now the orientations of the single images have changed, and also the positions of the images have changed slightly only, but they have also changed and will have an impact to our relative orientation. Also, after the relative adjustment has finished, we can see on the right side here on our Adjust Photo Stations pane that now the Results tab is active, and when we make it a little bit larger, we can then also see here different entries. Important for us is this status, which means now that we have a relative adjustment. The reason is because we did not introduce high precision GNSS. This data does not have high precision GNSS. High precision GNSS, either you have already in your drone an RTK system or something that provides you centimeter accurate positions for the images, or also in TBC you can run a baseline processing, but also here you need to provide some specific input data which is already somehow an RTK flight but not post-processed. But both ways are possible. You can already enter into TBC with post-processed GNSS, and then we will then check the metadata, and we can then extract that this data is already very precise. Or we can then also, when you have the specific files, run a baseline processing to establish centimeter accuracy. And then we would not only have a relative adjustment, but then after this reconstruction has done, we will run a second process, which we will explain in a second video more detailed, which is then the absolute orientation. And then you would also see it here. But when we go back, we can see here only to perform an absolute adjustment, you need either, in this case here, more precisely for the photos, the positions. And in our case, we have here a relative adjustment. So why cannot we directly go and generate an absolute adjustment always? Well, because this relative adjustment is now really here connecting the images to each other with tie points. And this is important because we need this connection between these images to know how they relate to each other. And also they help us now, as we have seen here, to establish better rotations between the images each other. And also during this process, we establish a better distortion model for the camera. And this is something we will now take a look in the report. The report itself now here is not an absolute orientation. So this is for us, we are not seeing now here absolute positions and accuracies for our data. So in our case, we would need now to measure these ground control points here on the ground, so that we have precise data to really then calculate the absolute adjustment. But if the images are not connecting, then we cannot even continue to the absolute orientation. So images that cannot connect in the relative adjustment, where this relative adjustment fails for these images, they cannot also later be absolute adjusted. So only images that have tie points to each other and where we know the relation to each other and they have a good connectivity, they can later on also get an absolute orientation, which means we can then use them later on to generate point clouds from them and to generate orthophotos from them. So in case you did not open the report from the dialog that popped up, you can always access it here when you go to either the results or the adjustments. Both have them, this icon, and it says Flight Mission Adjustment Report, and then when you click it, it opens it again. So I already had it open here, but just in case, if you don't have it open, you can access it this way. Also, when you go to the adjustment pack, there's one other button which is called Clear the Relative Adjustment. So if for some reason you made a mistake by importing the data, or you had to change something afterwards, then you can clean up, in this case here, the relative adjustment and then rerun it again. And it will then here set up the orientation back to the default. In case you were flying 2 flights, then if you did not use the merge flight missions, then you would have here in the flight missions 2 missions, and they would then be also here available in drop down, first flight and then the second flight, and then you can run both individual, the relative and absolute adjustment for them. If you want to run everything in one run, then you first need to merge them, and then you would then select them here first. So you would select the first one here, and then if there would be a second entry, you would highlight the second. I do it by example. I use the flight mission, so then you would select these 2 missions. Normally there would be here a second plane here, and then when you select these 2 and you hit the merge flight missions, then you can merge them into one, and then you can then adjust here the relative adjustment and absolute in one process. Okay, so let's take a look at the report. And as I mentioned, our main goal here is not now the absolute positions. So here everything with block adjustment is not so interesting. It's a standardized protocol, so it has all these entries. But for us, it's more important about the type point distribution and also the camera. So let's move to this part here. And when we first take a look at the flight overview, very important, only images where the relative adjustment was successful, which are the green ones, they will then also later be used in the absolute adjustment. So if you have here some red circles, then this would be not good, and then something here went wrong, and this would be something that we typically don't want, but this can be because perhaps your drone was just elevating from the ground and shaking, and it was totally looking in a different direction, so it's not overlapping with the other images, or your blend did not expose and it's black images, or the exposure blend was stuck and it only has half part of an image, or the image was totally blurred because it took a hit from the wind and it was totally here shaken up with the exposure time. So there are many issues why an image can fail in the relative adjustment. So typically you review the images first and you take a look if there was something going wrong. This would make sense. And then we want to have this type point distribution, and as we mentioned here, when you have enough overlap, we want that the type point is not only connecting 2 images, but we also want them to connect multiple times, because then we have a better redundancy and a better certainty about the point itself. And this is then this graphic shown here. This is then statistically showing one more time what we see here, now in numbers, and therefore here when we have here the most part of our type points is more than 3 or 4 times connected, which is good. Again, this here viewed as a histogram, and so if you would only have these 2 columns here, 2 and 3 times connected, then this would be suspicious, and then you would need to check what went wrong. Did you enter a wrong terrain height for in your JXL, or the focal length was wrong defined? So this can all be stuff that can influence our result. And then the camera itself, because of these type points, we were then able to calculate here a distortion model, which I want to show here. So this is the original one, just that we are aware how big the lens itself can have distortions. That means this is now the real distortion, and this distortion can be up to 112 microns. If you see 1 pixel in our project here is 2.04 micrometers, then we are talking here about distortions 50 times larger than 1 pixel. So that means, of course, if we don't use a distortion model, then perhaps we don't even see the ground control point in our camera model perspective. And now after we apply the distortion, so this is what we have done here. So this is now after applying the distortions, we can reduce the distortions down to 1/5 of a pixel in general. That means now the prediction where my point is looking at with this new distortion model will be better, and therefore the prediction in which image my control point can be seen, and of course later on when we measure point clouds, then also they will be correctly measured on the XYZ position, and causing us in this case here a nice and smooth point cloud, which causes then also a nice and good orthophoto. So, and this is for us the important part up to here. So as I mentioned, so afterwards is all exterior orientation stuff here, and the bottom is for us now not so important, mainly because we did not measure the ground control points. We see these values are extremely large. We have here 1.5 meters in the translations. We have here 2.5 meters in the ground, and in the GNSS we have here 4 meters. So these are huge values, but again, it's a relative adjustment, and therefore we are not interested about this. We are about the connectivity interested. So for us important, again, just to repeat here, are all the images relatively adjusted? Do we have a good connection? Do we have many multiple connected points? And is the camera distortion model well established? So this is the original one, and this is what we now can use as a new distortion model for our continuous process. If you did not start this tutorial from the beginning, I always try to follow here the PDFs that are existing for these demo data. And therefore we reached now step 5. And I will now leave you back to the PDF. I will not continue with this data set now with the absolute adjustment, mainly because in the next video we want also to take a look at the baseline processing. And we want then to run a baseline processing with the demo data from the DJI that is also available for download on the TBC tutorial page. And we will perform up to the relative adjustment with this other dataset, but in this case here with high precision GNSS. And in this process, when you apply the adjust photo stations process, there will be automatically after the relative adjustment also an absolute adjustment be performed. And what this where the difference is here, and how this can also make the processing more simpler. This is something that we will then discuss in the next video. For you, if you are now following this video tutorial, I would now leave here step 5 for you. You can here just follow the PDF, measure the ground control points, and apply the absolute adjustment. There will also be in this other video a video showing how to measure ground control points, but not with this data set, but with the DJI Phantom 4, mainly because then I cannot switch back and forth all the time. This makes it even more complicated. But I think it's very straightforward, so it's explained here. and also you can see here where the ground control points can be found, and also it will show then afterwards how you can create your deliverables, which will also be a video from the DJI Phantom 4, so it will explain you here these things. So if you're interested about more details about this, you can also find it in the other video. So looking at the user interface, this would then be the absolute adjustment, doing it here with adjust photo stations with GCPs, and this is the deliverables. There will also be a video about how to bring data further into TBC. Also, there will be here these functions then explained, how you can measure here a photo point, or how you can extract from the point cloud only the ground, which is part of the photogrammetry module. But we will also take a closer look to surface generation, contour generation, and also how you can then continue with your data in other products from Trimble, but also in third-party products. So thank you for watching this video tutorial, and I wish you a nice day. Goodbye.